Good day, everyone. Today we shall be considering complex number. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Okay, so let's look at introduction to complex number. And let's say we have the quadratic equation x squared plus 1 being equal to 0. Obviously, to solve this, we just need to move plus 1 to the other side of the equation, and that will give us x squared being equal to minus 1. And now, taking square root of both sides, square root of x squared, and then equal to square root of minus 1. On the left hand side, we have x, because square root of x squared will give us x. But now the issue is, what's the square root of minus 1? We cannot say it is 1, because if you square 1, you would have 1 actually. And we cannot say it's minus 1, because if you still square minus 1, you will have 1. So mathematicians tend to call this I. Some use j actually to represent a complex number, but we are going to use I because I've gotten accustomed to I actually, not as though it must be j or I. So it is actually, we are using I as our complex number. So at this point in time now, whenever we have I, we know it is square root of minus 1. Another way to introduce this issue of complex number is to say, let's say we have the quadratic equation x squared plus 2x plus 5 being equal to 0. Now, if we must solve this using the formula method, we know that our a actually is 1, and then our b actually is 2, and then our c actually is 5. You know, a is the coefficient of x squared, while b is the coefficient of x, and c is the constant. Now, the solution is given as x being equal to minus b plus or minus the square root of b squared minus 4ac all over 2a over 2a. This is it. And then if you put your value of a, b, and c into this, we have that minus 2 plus or minus square root of b squared, which is 2 squared, minus 4 multiplying a, your a is 1, so 1, and multiplying your c, which is 5. Everything all over 2 into 1. And so at the end of the day, we would have minus 2 plus or minus square root of, this is giving me 4 minus 20 all over 2. Yeah, this is what we would have. But we know that 4 minus 20 will give us 16. So we have minus 2 plus or minus square root of minus 16 over 2. We are still faced with this issue again, because square root of minus 16 does not actually have an answer. We cannot say it is minus 4, neither can we say it is 4. So what we do easily here is to introduce that our I again. We can say that this is actually equal to 2 minus 2 plus or minus square root of minus 1 multiplied by 16 all over 2. And then this can be written as minus 2. Square root of 16 is 4, so I can say this will be plus or minus square root of minus 1, sorry. Let me just correct this. So this will give me root of minus 1 multiplied by root of 16 all over 2. And so to simplify, this will be minus 2 plus or minus square root of minus 1 now, we've already said it is I. So it is I multiplied by square root of 16 is 4 all over these two things in brackets all over 2. So at the end of the day, we have a look of this form: minus 2 plus or minus 4i over 2. If you simplify for that, you will have minus 1 plus or minus 2i. That means 2 goes in 2 minus 1, and 2 goes in 4i will give me 2i. So this is what we have. So, and one concept of this is that mathematicians believe that every problem actually have a solution. That's what they believe. So if I get to the point where I have square root of minus 16, I'm not going to leave my problem, my mathematics to say I cannot get an answer. That's why we try to introduce the concept of I, which is complex number. Let's look further to higher power of I. Okay, so we've been able to establish the fact that I actually means square root of minus 1. What would I square be? Well, our I square will be minus 1 actually. And that's because if you say I square, if you say I is minus square root of minus 1, and if you say I square, means that you square the left hand side, you should also come here to square the minus 1. Okay, let me just correct this a little bit. Okay, so like I said, if you say that I is square root of minus 1, you should be able to say that I square actually should also be squaring the right hand side to square here, and the square will cancel out this square root, so you have minus 1 actually. That's how we got that. Your I cube is actually minus I. That is what I cube is. And what do we mean here? Obviously, I cube means I square multiplied by I. If you do this, you get I cube. And then your I square, you'll be able to say it is minus 1 already, then multiply by I. So that's how we got this. That's how we got what we have here. If you say I raised to power 4, what should it be? Well, I raised to power 4 will give us 1. And that's because I raised to power 4 means I square multiplied by I square. And I square is 1 multiplied by 1. And that will give minus 1, sorry, multiplied by minus 1. And that will give us 1. But minus times minus is plus. If I say I raised to power 5, then it will give me I again. How did I come to this? It is simply because I raised to power 5 is actually I raised to power 4 multiplied by I, and that will give us 1 times I, because I raised to power 4, we established that I raised to power 4 is 1, so multiply by I, you get 1. So if I say I raised to power 6, that will give me minus 1. If I say I raised to power 7, that will give me minus I. If I say I raised to power 8, that will give me 1 again. I want to notice something here. By the time we got to the 4th power, everything kept on repeating itself. The first one we have is I square, which is minus 1, I cube minus I, and I for 1. When you go to I5 takes exactly the same value of I, just ordinary I. I raised to power 6 gave us same thing as I square. I raised to power 7 gave us something as I cube. I raised to power 8 give us something like I raised to power 4. And if you go about repeating that all over again, if you say I raised to power 9, you will still come back to what I will give you. Sorry, I raised to power 9. Let me correct that. Let me write that well. I raised to power 9. We still have I, which is what I gave us. And then if we say I raised to power 10, we would have we have minus 1, which is what I square gave us. Everything keep repeating itself. After the first 4, the next 4 will repeat, and the next 4 again would repeat itself. So that's that. Higher power of I. Yes, look at this question now. I say evaluate the following: I raised to power 51, I raised to power 97, and I raised to power 150. Well, the basic idea here is to know that for every first 4 value of I raised to power 1, I raised to power 2, I raised to power 3, I raised to power 4. The next one, the value of I will repeat itself again. It's just repeating after every 4 powers, the first 4 powers. So that is just the concept here. So when you're given any power of I, all you just need to do is to look for the multiple of 4 closest to that number given to you. Like this question now, we say I raised to power 51. This is which is the A question. All I just need to say is, what's the multiple of 4 closest to 51? The multiple of 4 closest to 51 is 48. So I'm going to express that I raised to power 48 multiplied by I raised to power 3. And by this is when you add up these 2 power, you get 51. So now I raised to power 48 you can factorize 4 out of there. This will be I raised to power 4 all into brackets raised to power 12. Then multiply by I raised to power 3. Now what is I raised to power 4? It is 1. So this will give me 1 raised to power 12 multiplied by what is I raised to power 3? I raised to power 3, we did that earlier. It gave us minus I. So at the end of the day, what's 1 raised to power 12? 1 raised to power 12 is 1. So you have 1 multiplied by minus I. Eventually, our final answer will just be minus I. So quite easily done. You can use this for any other question. Look at the big question, for instance. You can try this on your own. Pause the video and then try. So if you do this, actually, you will I raised to power 97. The closest multiple of 4 in 97 is 96. So you have I raised to power 96 multiplied by I. Yes, so that when you multiply these two, you get 97 at the end of the day. And now I raised to power 96, 4 can be factorized out. That will be I raised to power 4 all into brackets raised to power 24, then multiply by I raised to power 4 as usual is 1, so this is like 1 raised to power 24 multiply by 1 raised to power 24 is 1 times I, so my final answer is just I. Let's take the last one, I raised to power 150. The highest multiple of the multiple of 4 closest to 150 is 148, so that will give me I raised to power 148 multiply by I raised to power 2. And so at the end of the day, factorize 4 out, that way I raised to power 4 into brackets 37, and then multiply by I square. Now what is our I raised to power 4? 1, so 1 raised to power 37. So this is quite easily done. I raised to power I square will give us minus 1. We did that earlier. So at the end of the day, this will be giving us 1 times minus 1, which is minus 1. So that's all about the higher power of I. So let's come to general form of a complex number. Well, complex numbers are generally represented with Z is equal to A plus B I. So generally we use Z to represent complex numbers, and they are written in this form: A plus Bi. Take note that the A is called the real part. The real part. That's the part that has only a real number. And then the B is called the imaginary part. Imaginary part. And so let's try this. Let's just try let me just give you some exercises here now. So let's look at this now. State the real and complex part of the following complex numbers. Or another way to say is, instead of saying complex part, you say imaginary part. Imaginary part. Whichever way, it is still correct. Imaginary part. Imaginary part. Okay. So the first one says Z1 is 3 plus 4I. Obviously, the real part, which we can call A, the real part, my A, which is the real part, is just 3 here. And my imaginary part, which we call B, is just 4 here. Please, the imaginary part is not 4I, it is 4. Okay, so that's just for the A. And for the B, we are given Z2 is equal to minus 1 minus 3I. The real part here, which is your A, you can say A is minus 1. And the imaginary part, B, is minus 3. Please take note. It is not 3, it is minus 3. Minus 3. And not minus 3I. Please take note of that. So let's take the following exercise on what we've learned on complex number before we proceed. So you can try these exercises on your own. Evaluate the following exercises. You can try this on your own.